Hey and welcome. In this video, we will discuss the type of time series model. Now, as we have discussed in the introduction part that we have few different kind of models and they are used according to the situation. I have also discussed that initial three models are not really very frequently used. They are, you can say, the older version and right now we are more into the ARIMA model or S-ARIMA model or ARIMAX is also there. So S-ARIMAX is also there, which we frequently use. In the case of multiple features that we have, we use vector autoregression or Varmax model. Varma and Varmax model both are used very frequently when we have multiple features. And so on, each feature has its own quality. And this model, last model, is neural network, the deep learning part. We will also discuss the theory part of it at least. And when we are done with the deep learning part and especially the LSTM part, we will continue that LSTM part with time series here. So let us start with autoregression model. So autoregression is quite simple and straightforward. Let me put some theory over there. So to import the AR model, again, autoregression is simple. We are using autoregression, and it just gave us the future future observation by studying the past. Because basically, check the history, give us the future. That is how it does the job. I hope you recall all the important points of time series that I have discussed before. So you clear about that. We should not be predicting too long and stuff like that. So to import this from models dot tsc dot ar model import. All right. No, not this one. I've already done this. Auto. Yeah, there it is. And yes, we need some random values too. So I'm not going to, give any random value. We will just use a random. Uh, just import random from random, import random. That should do. It is saying cannot name auto regrow. I hope I have not made the mistake. This should do. Perfect. Spelling was wrong. So what we do here, we have imported. So this is how you import auto regression. And once you import the auto regression, you need a random data that we will creating. So random is a simple method that we can use to do that. Okay, you call it and it gives you random values and the range of it, you can see it in the definition, acts in the interval of 0 and 1. So this is the range that we will be getting out of it. So let me copy this, put it here so you have the idea. Here we go. So it gives some random value. What we will do, we will create say 10 values random and just get the output of it. So to create a data, what I will do is simply close this one, and I will do something like this, that I will simply map it with something. So lambda will work here. So lambda x, where x I want to add with random, that will do. And I want to give a list, so simply give a list here where range 1 to 100. That's it. Let's make it 101. That will be better. And this will map it, and a data will be given to me. Let's try. Oh, of course. So we have this kind of data that we will be using. Okay. So picking this, putting in data, and what I will do next is I can create data frame too if I want to. So there's no issue with creating data frame. I can simply go ahead and put it in a data frame, or you can use it directly. Both will do. There's no issue with that. So import pandas as PD, just to show you how it really looks. PD dot data frame, and putting data inside this. So it's look like this, and just printing the head for you. Head of 10 line should do. So clear picture where you can see this is our data set that we will work on. So I'm creating data set like this, and having some random values, and it's an incremental order kind of thing. So we'll just make it data again. Uh, DF is better name for now. And what I will do, I will simply mhm, DF dot 10, DF dot plot. Okay, a trending line, incrementing line is there, which is like this, is going up and up. Little fluctuation is there, as you can see, a very tiny fluctuation is there. And this is my data that I'm going to use to work on. Now again, it's in raw data, just a rough idea to get the job done. Not doing too much on this. Okay. Main aim is that we have imported this, we have this data, and we will use auto regression. So now time is, I will say, model auto regressor, and there are lags also, so we can give a log lag too if you want to. So yes, lag can be given here, and uh, okay, so let's give these two values, endo and the log. So if you go this in this way, you can see that it is also saying that it is p-value, and you can get the conditional value. Lag is the integer number of lag to include in the model. If the integer or the list of lag indicates the include, for example, 1 4 will only include lag 1 or 4, while lag 4 will include lags 1 2 3 4 all. And that means basically, if you give these two values, it will pick only these two values. If you give just 4, that means we'll go from the starting point till 4. That is how it is working. So let's not too much use too much head over there, and let's move a bit further. So if you just run it like this, you will get an argument missing, because endos and lag are missing here. So you have to give these two values. So first value is endog, and so you can give the data, and the lag. I'm giving lag 1. That should do. And moving further, so this is my model. Now model can be fitted. Now model may predict, and the predict value has to be given. So no, as I was saying that moving average takes the error in the calculation and do the prediction as per residue. So moving average work over the average error part and then predict the arima the AR model auto regression model work on the history and then predict the future. Now what we can do instead of importing it separately like we have imported arima auto regression like this, right, without importing it like this. Okay, let me go back there. So what we can do instead of doing it like this, what we can do, we can say from stats model dot tsa dot arima not is dot model import arima. Now what I'm trying to do here is there is a something called order. Okay, order is given as a parameter, and if you keep the order like we have p, d, and q, where p stands for AR auto-regression, d stands for integration, and q stands for moving average. If you keep these values 0, so if I want to use AR, I will keep the other two 0. If I want to use moving average, I will keep other two 0. In that fashion, by keeping these two 0, I can use moving average without even importing the moving average part. That saves a lot of energy and work. Now let us move this, see the option. All right, this part can be removed now, no issue. So this is our array model, and now we will use it for creating the model. No, it's same scenario. It goes like we will fit it first. So first create AR. That will be Arima. Oh, I have not run it yet. There we go. DF is not defined. I think I have to again rerun the file. Something might have occurred. It should do perfect. And saying Arima, right? And this we have parameters, right? We have the order option. Now this is the order that I was talking about. All three are 0 by default, and if you're not giving the value obviously, and you have to give the endos, that means the data that you want to use. That's it, and no other parameters. So data and the value. Now autoregressive model is P, and moving average is Q. Mixed autoregressive average model is Arima P comma Q, and integrated model is Arima PDQ. Seasonal model is PDQS. S is added to it, and regression with the error following model is type of model. Now again guys, we have these values which you can use. Again, you can read it completely. It says that it is the model autocorrective reference and moving average component. D is always an integer, and while P and Q may either be integer or the list or integer. Now as here is what you can see the new thing is, which is the for seasonal data set. So if you have season data set, you add a s in it, and default values are all four as 000. I think details are given very deeply here. You can just read it. Now I'm not going to read complete thing, guys. It will take a lot of time. I don't want to kill time here. But yes, this is how you declare the Arima model. You give the data in the Arima order, and that will do the job. So these are the few steps that you can use to get the clarity. Let me put it in the comment here. So just have it for the reference. So this is how you actually get the job done. So what we are going to do here is declare the data. That's my data, comma. I will say the order. So order will be for now 0 comma 0 comma 1. So that is my moving average, and now I will use it. Let's not use this cell. Let's move to the next cell and giving the values here. So AR dot fit parenthesis, and we give it to my, say, MM model, so moving average model, and that is how I'm fitting it. I'm just move forward. Then MA. Oh, let me do it. MA predict, and now again we see how many values are required. So ending and starting value is required, same fashion. So if I give here 100 comma 110, okay, this will give you the prediction value. Now obviously the values are going to be different for both models because they are working in the different patterns. This is the prediction that has been given to me, and let me also say ms dot summary. Oh, so here's the summary that you can catch. It gives you all the details. Again, guys, a lot of things are given to you when you ask for the summary. And AR is real imaginary modulation frequency is given to you. Intercept is given to you. PQ error, standard deviation error, and coefficient values are given to you. Z given to you. Observations are 100. Log likelihood, AIC, BIC, and HQIC. And yes, date and digits are given to you, so you can use this to get more clarity over the data set. Again, guys, not really something that I want to discuss at the moment. Let's not dig in that part. So let's move on. So that's it. That's how you get a job done. Let me know of this too, and that's your moving average right now. So next is the Arimam autoregressive model. So in this same thing, guys, same data frame, same data will be used. So question is what we're going to import in there. That is more important. So I will import, or you can say use ARMA model. Simply same scenario in the order you give the center part 0, other two parts some value, and that should do your job. So all you need to do is pick this, put it here, ARMA, and let me move capsulon MA, and say I put 2 here. Now these values 2 and 1 are taken from the observation that will teach you in the project itself. For now, just for practice, I'm giving you the value. Now all you do is RMA is not fit, and say call it M only. It's better to call this M, and then make this as M dot fit. So these two should work. So let's go. There you go. So it's a warning that non-stationary starting aggressive parameter found using 0 as a starting parameter. One non-stationary starting aggressive parameter. Okay, so I'm giving two in a state. They're saying you should not be giving that. So okay, that is not really an issue at the moment. Let's move a little bit further. Let's see what happens. Now it usually is a hit and trial. Sometimes you get the error and you have to try with different values, and that is completely okay, guys. No, there's no issue with that. Here is your prediction, and that's it. So this is your ARMA model where you give center part as 0. Next, ARIMA itself, where you give integration some value, so it can be ranged from 0 to 2. Usually we give 1 or 2 here. So ARIMA model. Next, let me pick all actually, so you don't have to worry about copying and pasting it again and again. Okay, there you go. And let me put it like this so it saves some time later. I think that's more than enough for the moment. Let me create a few more cells. So just for the sake of saving some time, and here we go. And copying all three here, putting it here, then taking this one, putting it here, taking this one, and taking it here. Now at least we have all the types that we have, and let's make it bigger and create few new cells. The same thing goes on in this. The model will become something else. So this time the model will be proper and the values will be different here. We can have the range of I can be in the range of 0 to 2. So I am taking 1. You may take something else. That is okay. So this then predict and copy and fit it. Then you just predict it. That's it. If it gives me the error, I will try some other values. That's the simple hidden trial I'm going to do just to save some time. So it didn't give me error. So it is perfectly fine to use it like this, and values working perfectly. So let's jump to the second part is as arima, which is what I want to discuss more than the upper model. So simple ponds, making new cells. We'll use DF only again, and we'll go with it. Let me remove it for the moment, and from rel.tsa, space dot max import max. That's it. Let me also put some definitions there. Basically, the method is suitable for time series with trending or seasonal component. So basically, when you have trend or season, Arima does not work well. We cannot use Arima there. So if you have seasonality in the data set, you have to use as Arima or Arimax, whatever you want to call it. Now you can create an Arima model from Arima 2. That is also practical, which you may run this and let me create a data set. So model equals to the max function where we have to give order. Okay, for now I'm writing anything, not thinking too much, and season order. For season order, I'm giving say 0, 0, 0, 0, 0. That should do. Now let us discuss what these values are. Let me show you the definition. So obviously you have to give the data that is required, and thus the values you have to given. Then order can be given, and with order you can give the season order. Now if you scroll down, so this is a name, season auto regressive. Let me also remove that 1 second. I imported wrong one. Let me import it the correct one. This should actually go down, not here. So this cell should come after this Remax and this one also. So let me shift it. I have to import this differently. So from actually we can go with it too. There is no issue with that either. So let's keep it same. Doesn't matter. And run it. This one and this one. One only and now yes, data is missing. Data is what we have to give. That should do. And let's create some new cells. So we have some space and anima is equals to m dot fit. We have parameters here too, so we have to give dips. All right. So, so let me show you the definition first. That is I was doing. So here you go. If we go roll down seasonal order, iterable and optional. We give P, D, Q, and S here. So orders are given here. Orders are given before and after the both. So seasonal order is also given here. Order of the seasonal component of the model for the AR parameter difference MA and periodicity. So how frequently they are working and so on. And if you have any seasonality in the data set, you give different value here. I've given 0, 0, 0 because I don't want to use it at the moment. And where it is, D must be integer integration and you may either be integer of AR model and their value can be different. Else iterable giving specific ARMA lags in included in as is an integer giving the periodical values. Often it is 4 for quarterly day or 12 for monthly data. Okay. So 4 for quarterly, 12 for monthly. That is what we give for S. So S value is fluctuating like this. So in the last value, the last zero can be 4 if you want to go quarterly or if you want to go seasonal. Means monthly wise, you can give 12 there. And so on, we have other parameters. You can always open it and go through them. You can go for the documentation and read over complete documentation. It's a very long value documentation actually. If I keep scrolling down, you might even see some examples there. Okay, examples are not given, I believe. The examples are not there. Doesn't matter. I hope you get the clarity of this. And let me close this. And here now, mm, dips. So boolean optional value set to true to print convergence message. Okay. And now by default it is, I believe, right.
Okay, so let me check the values options that we can give here. So, so to the option, we will this go back to 5. All right then. For now, make it false. Okay, warning again. And I think we are good to go. So, Sarima dot predict me 100, comma 110. And here we have the prediction. And so, what happens if we don't give it? Oh, my bad. Just like that. And copying this. There we go. There you. Same values again. So, guys, this is how you get it done. You simply give the values for seasonal and get the value done. Now, seasonal trend is something that we have to observe. Seasonality is something that we have to plot and check. Seasonality in this case was not that much present, so we didn't bother about it. As I've already plotted the data, and you already know that there was no particular trend going on there. So no use of putting the seasonality or talking about seasonality too much. It is just an example. You get the idea that how every model is working. We will do a proper coding for each model separately on a project too, where we have decent amount of data and trend seasonality will be there, and we search for it according to the presence of seasonality and trend. We will handle the model. So basically, what we are going to do here is exogenous regression basically means that we have another value, which is you can think of it as a generic fashion that we have another feature which is calculated at the same time. So in generic level, second feature which is taken as the same time. Okay, so your data set has two features. So you can think of it, and you can have two features working together. So external variable are also called convariant states, convariates, and can be thought of as a parallel input sequence that have observation at the same time step as the original series. Now, what we're going to do here is we are going to create another data set for this. Okay, so we will use both, and we will create another data set and work over it. So to achieve this, what we will do, this is the later story. First, we have to use the mapping again. Let's copy the mapping that we have done before for the data. That will do the job. Here we go. And all right, then data one is this, and data two equals to same list again, but I want to change the values. So making it as 1 to 21, that should do. And here we have the data. So we have two data set here. We start from 100, 1 to 100, and then 100 to 101 to 200 and 200. So that is total 100 and values are there in both, and just confirm the length too. So data 200, latest 102. So perfect. Now the same thing, we will import the data set, Remax model, and the other thing will be there. And we have to give data, comma data 2, comma, and creating new cells, m dot fit. Predict again. I'm giving 100 and then 10. Oh, this time it will not work because obviously, let me change that. So let me make it 100, comma, absorb to 200. That should do. We have the prediction here. And this is how you get the prediction in here. We give two values and exorb is has to be given here for the ending value. That's how the max part work when you have two more features. And that bring us to the next part, which is vector auto-regression, where we will discuss where we have more than one scale. We don't have scalar values. Now we have vectors, means we have another direction too. So more than one feature is involved, and let's discuss how we work with that.
So next is vector autoregressive (VAR), and vector autoregression is a method that is next up to the time series. It is an extension over a AR model when you have multiple parallel time series. Example, multivariate time series, which means you have more than one features, and the main axis remains as time series. So in addition, for the model specify order of AR equal P, same notations will be kept here, and VAR is also P, and the method is suitable for multivariate time series without trend and season component. Now, guys, again, it is without trend and component season. It is exactly AR but with multiple variants. Okay, so guys, the thing is that you suppose you are having say multiple features. So I have feature one and feature two in this case, and the main axis, the time series remain the same. So time axis remains the same. This is my time axis which will be there. Okay, and we up to this point we were working with the x part, which was a feature, and now we also have another feature which is a y. Okay, so if you have more than one features, you work on VAR. Now VAR is there, another extensions are there, so we will talk about all the models. The only thing that we have to create now, we already have data, okay, that we are working on, and that is one data, and we also have a second data. We will use both the data. So data 2 is also there, which we are going to work on. We'll take data 1 and data 2 to and create a time series VAR part. So let's start working on that. So from start models dot tsa, it's the time series, then we are looking for VAR. So vector is what the name is. Mhm. Vector AR dot VR model, import VR. That's my library. Now, guys, how I remember this is quite simple. We are working with VAR, so vector is the name of this. V stands for vector auto regression. So vector underscore AR is the name that you have to remember. Then it is always going to be the name of the model and the model name itself. So it's AR underscore model, VAR underscore model. It is always same, and import VAR, and that's it. Always remember the core library that you will always use for any model to import. It's statmodels.tsa. So how this is how you memorize. Again, guys, you never need to memorize, to be very frank. I never try to do that. Just use it again and again, and it will be in your memory. So once you're done with this, guys, we can create a random, or we can do one more thing. We can create this data again. So data 1 and data 2 is already there, we already have the data. Random is not being imported, so I have to import random. So let me import random. Let me write it again, from random import them. That should do. And we have the data, so we have data 1 and data 2, we are having 100 elements there. And yes, we can use the same data again. So what we are going to do, we are going to use the data 1 and data 2. So using data 1, data and data 2 from above. So guys, what we are going to do here is we are going to use this data and we are going to create a variable for, so we say model for now, and say am or model, whatever you want to use a variable name. And var is what we are going to use. So okay, I have not run the cell yet. Let me check also if it's working or not. Then parentheses, and yes, we have parameters there. So endos is the data only, guys. The exhaust zog is the adding data. So data 1, data 2 is has to be given. And yes, the dates if you are having anything like that. So you define the values. We are at the p position. So it is again going to tell you that. So endos array, 2D array, both are available, and independent variables is endogenous, which are available. And you define the other values. So let me go ahead and try the values here. Now if we have data 1 and data 2, so what we have to do, we have create a var data. And what do I mean by this is I want both the datas in the data frame forward. So let me give you an example on this. So say pd dot data frame, and I will just put my data to. So let's not do it like this, that won't be. So my data is simply data comma data 2. So var data, okay, not exactly what I was looking for. So dot t should do. That's it. Mhm. Okay, I have to check data too. I think something is wrong with the data. Let me check data. But data is already two columns, not a single column. Let me check on that, how it already happened. This is going to create a single range, right? Let me run that if that is properly working there. I'm not modifying the values, I hope. Yeah, it is single. It was, I don't know what, uh, some sort of mistake, I believe. And data is like this. So our data should be perfect now. So var underscore, and that should do. Now we just need to transpose it. That should do. Perfect. I think the access what is I didn't define. So hmm, so oh, let me check the definition. Maybe some parameters is missing. Okay, looks fine to me. And this is this column data. The, the parameters are fine. I don't think I have done anything wrong. So okay, and you define the value and give the value, and you get the results. Perfect. I think everything is fine. You can give the column names if you want to, but I don't want to give that column name. I'm not required at the moment. So I will move like that. So we add this and make it a v data. That should do, and that will do. Now, obviously, one undo, then this is missing, so I have to put this value not here. Let me run that and somewhere here where I will give the v data, and the am will be fitted. So dot fit parenthesis. That's my model now. Now model dot forecast in this case, and model dot y will give me the values. Yes, and because it is a parameter, guys. Y is just a parameter here, so which gave us the value. So y is a parameter. Basically, what it does. Let me show you the output of this too, so you're not confused on that. So this y model is giving me to give you this array, which has both the values, and complete values are given to you. Now again, I don't want to print it completely, just few rows in case. So let me slice it for you from starting point to 5, and that should do. So this is what it is giving me, give you values like this, and first row is still 100, second is from 0 1 to complete, and that is your y complete access. And let me go in the definition again. Let me check few things. So here's the steps has to be given. So y has been given. I've given y. Now I will mention the steps, and I think that is it in the definition. Not much is given there, which is not really present to see. To be very frank, a little more details is what we usually expect when you call this definition. Because now, if the definition is not given, the only option that if you want to do the R&D, the only option that you have to go in the documentation of sklearn and look for these precisely, which takes a lot of time. So you don't want to kill your time like that. So that is okay, but I'm just giving you an idea. Let's move forward then. So not giving much step size, just going to give much step size one. Again, if I can just print that part, minimum access forecast step. So what is the minimum desired number of steps that you want to forecast? That is what you definitely define. So let me put it right here, so it makes sense. So you just use the history data, you get this step. So I want to predict just one step ahead, and that is what it will forecast me. And let's run it for you. So okay, I think it's steps, not steps, if I'm not wrong on that. Let me check that. Yeah, it is a steps, not step, and that is what it predict for me. It just predict forecast for me, and you get the results here. So if I just pick it and just put it here, step size say 10, so it will give me a 10 forecast, and that's all. This is how you just predict in VR. Now VR, the main thing you need to mind, guys. No, things you need to notice that data is given in a single shot. You have to give data with the two features. So you have to have the two features here. That's what you give as an data. V data is your data frame which has two features, and you are giving it as an input. Second part, once you're given it as an input, the forecasting goes like this. You have to, you are not using predict here. First of all, you're not using predict here. If I literally go ahead and say model predict and I press tab, there is nothing. Okay, there is no such variable. So forecast is what the name is, and you forecast, you give your y actually give you the historical data. Y is basically going to give your both axis, or you can see the both features to the model, and then it forecasts as per the steps you want to forecast. I am forecasting 10 step. Look guys, I have 100 historical data set. So 10% prediction is okay. Best prediction is 1%. Up to 10% the prediction is okay. More than 10 percent prediction ahead is not admirable. Usually the after 10% of prediction, the steps are never going to be good, so you have a good chance that you are making a mistake at the end. So that is all you want to know about this. So that's, I think, it for the VR part. Let's move forward then. So guys, in this vector Verma, the VRMA, so vector autoregressive moving average, where we will use VRMA. Now guys, VKR, it is a generalized way of working it. And okay, so it is an ARMA model, ARMA model, where we are using multivariable, well, multivariate time series. That is why Burma. Vector stands for multivariate only, guys. And what we are doing here, we can use AR and MA by P and Q. So we can give the define the P and Q parameters, and by that we can also use Verma model as a VAR model or a VMA model. So both are equal. I'm not specifying VMA model. I hope you get the idea how VMA model goes on. So I'm jumping directly on this. So from stat models dot space. Okay, something I missed, I believe. Stats model, yes. Dot TSA and dot state space. Sorry for that. So one max import one max. Now this is how you import. Now guys, uh, state state space is something that we have already used. If you recall, doesn't matter. We have these models that we can use. So NP, we one max result, wrap, and so on. So these are the features that you can use from here. Now let me move forward, and here we go. So in this we use state space only, but we use it then as array max, and from as array max you use it. So if you just press tab here, you will see all the models which have anything varying. So as array max, simulate smoother and stuff, we Vermax, all these are here. Okay, so moving forward, I think we are done with this, and here we go. So let me remove this, not required, and here we go. So we are going to use Vermax, and same thing, guys. Again, the data is required and stuff is required, so we have to work on it. So equals to, you have to give the data. So data will be the same. I will use the var v data, and again the order is defined, guys. Now order is something that we need to define here, and order goes like this. Let me show you the orders. So order goes like iterable object p and q is here, and in the order we have p and q order model, we are model parameters to use. Okay, so this is for the order part. Let me move this line so we don't have to worry about it, and bring it back. Here we go. All right, so we defined the data. So we data comma, and this the value. So we are, if we are going for both model, both can be 1 comma 1, and for now just giving any value, guys. Don't really worry about the values. Obviously, if we want a VAR model, we use 10, and we want VMA model, we use 01. That's it. So that will be the model number, and so it is a robust. It is giving me a warning. If it doesn't work, I can give different values too, and that I will try. No issue with that. So let's move forward. Don't worry about too much at the moment, and create a model. So I will just create a model equals to am dot fit. Okay, fit parenthesis. Running that. What did I miss? Array must be of two dimension. One dimension array has given. Okay, that is one mistake that I've done. Let me check how it is not getting fitted. So var data is 1D or 2D, that is why I have to check. So var data dot sheet, but it is not array, so it will not work. Okay, 2 and 10, that is exactly what we are having. So let's change it then. No issue. So let me check the parameter. DISP is false is what I have to use. So yes, that is one parameter I have missed. So DISP is equals to false, and need to give the value now. So the RS says that we need one dimension is given, we need two dimension array. So shape is correct here. Shape is not giving any error. So let's check the endim. That should do. Dimensions are two only. So dimensions are correct. So if I run this and then this is not working. So let me check on this part. Uh, Let me this is where our VAR data has been created. So let me run it again. I hope it is not replaced by anything like that. No confusions are required. So okay, something got wrong. Now what happened here? Let's check. Add a current number type object. Check input cost to numpy type. Okay. Uh, Let me check what I missed again. So this. Oh yes, this is also required. V data is required, and I'm giving var data. That is what I'm missing here. So V data should be given to it. Uh, yes, V data is the name. Dimension of V data is 2, but correct order. So this should also work. I think something again bugged it. So I was using the wrong one, and check input data as NP as array data. Okay, okay, okay. Cast to be number type uh, object. Okay, okay, okay. No issue. It requires an array. I'm giving in pandas data frame. That is what it is saying. So there is no issue. I can just import numpy. So let's use the easiest way out. So import numpy as np. Then give it here and make it v. See if it works. Np is not defined. Oh my bad. So it worked. Let's see if it is now working. So these things are resolved. So var max is done. Am dot fit is not working. Let's see the error. So cannot interpolate with all the object type data frame column in the data frame. Try sending at least one. Okay, it is saying it's not a numerical data, which is not correct. Data is numeric. There is no issue on that. So what I'm missing next. Min max NP array, this order. I think this line is correct. So just want to check on amp. Okay, we have this one. Oh, yes. Let's see. It's an empty value, which is surprising. Hmm. VData is two dimension. Can I print VData here? Okay, that is the issue. It is all hodgepodge here. That is why it is giving so many issues. Okay, let's go back. VData transpose. Okay, first of all, the data part. So I believe got to run the complete part here. Is data normal here? Let me check. Data. Yes, data is completely corrupted here. So I have to go back on the data part. How the data is getting, messed up. I'm not really sure on this. Data. Okay, this is working fine. This should work fine now. So perfect. And this should work fine. If it is giving error, that there is an issue. If this works fine, this should work fine too. That means yes, now it is correct. Now, all right. Finally, I have some results, and let's remove this. Not required. Finally, done with it. So guys, this is how you literally stuck sometimes, and there is literally you cannot do anything about it. You have to resolve it, check every variable, check every parameter, and then you actually reach to a point where you have a chance to understand the stuff. So it takes time, guys. It takes a lot of time. uh, Chicks. Let me also see if we have 2 underscore 3 underscore this not what I'm looking for. Let's leave it. uh, so that will not be found. Am is there, the max object is there. All right, no issue then. Hmm. So let's run this. Here we have the forecast. And yes, same things you can give again, step size and all. So you can define the step size, how many steps you want to go for, and stuff like that. So this is how you go for the forecast here. And we have to go into features. Here we are given this one feature, and done. So vector autoregressor moving average with exogenous regressor. VAR-max is the short form. So VAR-max is the extension of VRM model, and it is including the exogenous variables which are not really dependent on auto features. You can say it is a multivariate version of the Aremax. So we have two features included in the dependent variables, and exovariant also called covariant and can be taught as a parallel input sequence that have observation at the same time as the original series. Now, guys, original series will have two features, and then we have a third feature which is taken at the same time but has nothing to do with the data set.
Now, Vermax method can also be used to model the some model with exogenous variables such as varx and vmax. The method is suitable for multivariate time series without trend season component with um, exogenous. Now, guys, seasonal data will also be dealt with the coming project where we can say. And let's start with the models. So, guys, first we need to create a data set. So, requirements are there. So, requirements are that we need to create a data set. I will create something like this where we have feature one, okay, feature one, comma feature two, okay. That will be my one data, and I will have an exo data. So exogenous data and exog data basically have a feature three. Okay, that will be having, and where I would say F1 is correlated to F2. Something like that I want to create. So I will what I will do is I will simply map it. So map this with the lambda and what I will do I will take x, okay, and mm, I will take x and y, guys, not just x. So I would say that I want to take the random value. So obviously I will use the random here. Random is inputted above already, so I will not input it again. So for first value x, I want to just take the random. Okay. And second will be y plus random. So that should do. And still it will not perfectly fine. So what I can do, I can make it like this too. So I can take the x plus random, and with this x I can map again. So it will be like I will take this value, and in the next mapping, what I can do, I can just take this x and then map it again to random and add some value to it. That looks better to me in the case. So in this case, we need for what will be the range for x. So for I in range, should make it 100 for now. That should do. So sorry, not I x here, and for x in the range of this, and this is all will be in a list only. So list, and that should be my data d1. Okay. In the next data, what I want to do, I will simply pick one value for it. So d2 is no different anywhere. So we'll write list. Uh, let's make the lambda first, so then I will move forward. So what I will do, I will just map it, and so I will take this uh, y, uh, where the y will be added to random. That should do. Now, in this case, what I want to do is I will simply add it, and I will take the value from there will be a comma. We are mapping it. So from for y in d1, that will be a value. So that should do, and that will give me a d2. Putting this complete in a list and bad and will be here. See, that should do. And correcting the spelling, putting the value, and let's see if it was working perfectly or not. While D1, that should do. Okay, for is not working. Just comprehension and mapping are different. I'm doing it in the wrong way. I'm thinking of confidential. I'm doing it on this way. So range 10 will be in the list. I could have done this with confidential too. I don't know why I have not done that. Not really sure. So I'm thinking of confidential and doing a mapping. So that is why I was so confused. So guys, this is how it really going to work, and this should do. And D1, D1, 2 are there. So let's say D1. This is my D1 values, and say D2. This is my D2 values. So it's 1 point something, and D1 is 0 point something. Okay, that this will do. This should do actually. So decent enough, I believe. Decent enough values are there. They are somewhere correlated to each other, and that should go in the single data frame. So what I will do, I will just make a single data frame where I have these two lists working together. So say the main data D3 will be having D1 comma D2. D3 lies till the top five. Okay, not what I was looking for. Obviously, what I'm thinking. Mhm. Poor decision. Guys, now the thing I have done is why it is wrong. Let me show you that too. So if I have two lists, I'll give it in inside a list, say two, three, four, and say five, four, six, and seven. And if I print this L, you will get this. Okay. So this is what is actually happening. We are having this value like this, which is not exactly what we are looking for. Transpose will not work on this. It is not a data frame. So obviously, I'm making a mistake here. So what I can do here to correct it, so what I can do here is pd dot data frame. I can just put it there, and that will create a data frame for me, which has D1 and D2 as two feature. D1 comma D2, D3, and as like this. And again, it is not exactly the way I was expecting them. So I have to transpose it. So to transpose it, we will do T top, and that should do. Now, to make sure that it is perfectly fine, I will let D3 equals to D3 dot transpose, and that should do. This also not required anymore. There we go. Perfectly fine. And we are having, guys, again, there are far more simpler ways too. But whatever comes into my mind first, I just go for it. And then, then I think of, yes, there was a simpler way too. So it happens to everyone. Guys, moving forward, we have this data, and this uh, data has two features which are dependent to each other. Now, guys, we are done with this part, what I was telling about, the data part. We know Exo data, which is F3. This will be again a random data, which will have some random values. So, taking the data like simple, in a simple fashion, guys, I'm just going to pick this and pick it here. D underscore Exo, and that should do. Here we have the values. So we have the data set now. We are ready to, go for it. So now we have to import. So from uh, from stats model dot tsa dot space dot import one max, and there we go. So perfectly fine. We are importing one max now. M equals to one max. Seeing the parameters, axo data is required, another data is required. So that will be my D3, D3, comma, axo data is D underscore axo. And yes, next is, let me check, order is required. So I will give the order. So it's one max. It should be one for now, and that should do. And one for one. Okay. M dot fit. In the fit, is there any parameter that I need to know? Looks good for now. This false. Uh, let's enter it. Oh, I'm not taking catching it. It should be in model equals to, this is how it should go. And then model dot forecast. mm, It takes the value obviously, and out of shape operator in the model regression actual value by every argument. Okay, let me go back and check it. So let's go absorb here. I hope it is in the feature. Uh, Not displaying anywhere, but see 100. I think it should be in 2D. Maybe it is working like this. So let me check the 2D too. Okay, both ways are okay. So no issue. So 100 is giving me this. Let me check which is not in the values. So say something like that. They should give you the values. Hmm. Okay, this is I'm okay with this. No issue with that. So that's all for the Vermax part. I think we are good to go. Let's move forward then.
So, in simple exponential smoothing, in short, SES, simple exponential smoothing is a basically, you can say, is a time series forecasting method for a univariate data without a trend or seasonality in it. It is required for the parameter, a single parameter that is called alpha, also called the smoothing factor or smoothing coefficient that we have to pass. The matter is suitable for univariate time series and without any trend. That is the main tag point that we have to remember, and that's it. So let's import it. So you have to write from, sorry, stats model, I tsa dot, oh my bad. Oh, here we go. So this is what I'm putting, guys. Again, I will use a random or maybe mapping to create it. So again, I'm writing random. So I've not imported the above line yet. Random from random, import random. That will be easier for me. And simple mapping. So I will just pick the upper line. I don't want to, I can use this too, guys, again, but it is getting confusing and confusing when I use the same data again and again. So I don't want to waste my time like that. So I just make it data D for, you know, SES. That's easier for me. And we will have a random data which will work for us. And that's all we need. Obviously, we have to create an model. So I will write oh, let me make it again a coding cell. And equals to simple smoothing. Let me make it this. There are the parameters. Now ndog is what you will give. So dsc is the data that you will be giving. Apart from that, you can see there are some parameters that we can use. If there is some example, that will be great. No example is given again, so no issue. Well, no issue with that part. And dscs is your data basically that you can give. And the other steps goes in the same fashion. You just fit am. So I would write am, not really am. I will write model dot am fit. That should fit my model, and then just model goes like predict. And they, again, we are back to predict, not forecasting. Only V or any model name that was starting from the V. So vector part has this forecasting part. If you're going for simple codes, and it will be always predict for you. And yes, the value has to be given. So 100, say 110 again, I believe that should do. Yeah, there's your answer. So this is the prediction that you are getting from the data set. And your data d underscore ses is this. So you had data till 99 and you're getting the values after that. So I'm predicting from 100 to this values, and that is what it is giving us. So if I just, let's just won't work that way. So, but at least you can do one thing. I can pick 99 to uh, not 99, say 96 to the very end. That should go the last value of you. So, these are my last value. These are my predicted values. 100 is always going to overlap each other. But after that, it just predict that. I think the values, okay, the values that we are getting is almost, same. So no issue then. Just make it 100 and that should do. So we had the next prediction. Mm, at least two will be good. Yeah. That is one thing we have to check. Now, guys, that is how you predict the values. Again, guys, when you use the actual data set, the values will be different and the quality will be different. But at least you get the idea how to implement this. The same steps are there. And let's go for hot filters then. So hot winter exponential smoothing is simply used for forecasting the time series exhibiting both trend and the seasonal data. So we are assuming that we take in the count of trend and seasonal in this. The import is simple, straightforward from stats models dot tsa dot sorry hall winters import, that is exponential smoothing. Now, instead of simple smoothing, we are importing exponential smoothing. Because data will be same, so I'm using the same data set, not going for any complex coding this time, and going straightforward, same code, same thing. So we create a model too. So in the next cell, I would like to create simple arm that will be having my, and here we go. Oh, I have to give end of, yes, d, that should do. And now I'm model will have m dot fit. Here we go. Then we will simply predict the value. So that should give you the value. So this is how you simply predict the values and get the output. Now I can give this 100 too, so that will not change anything. Now the implementation of same. So I believe the implementation was same and the logic was same. And almost in every algorithm we have done almost the same things. Main aim was of this sheet of this complete code and everything is to introduce you to every algo. We notice the algo type, the variety in the algos, and we also notice that even the same data was there. Way we fit it is different, way we predict it is different. So some has some arguments, some has some parameters to be passed, some don't need any parameter, they can straightforward go and get you the result. Now in exponential smoothing, exponential smoothing and hot winter's exponential smoothing has these are the three main, you can say, algos. In exponential smoothing, we don't have trend and serial and counting. Uh, hot exponential smoothing has trending in count, but seasonality is not in count. And hot winter exponential smoothing is going to count. Now you can keep the seasonality memory with the winter. So when winter is there, that means the seasonality is also counted, and hot exponential going to count the tradition trend in it. Now, these are three types. These are three ways of implementing. So, how to enter exponential smoothing is what I have implemented. This was a simple trend, and I think that is pretty much all to explain in this. So that is all for the code days. We will do the next part. The remaining parts of the code. Again, these algos are not finished. We will try to do some projects. We will try to do some code on each algo, and that is how the things will go on. So time series introduction was required. So I have almost added every algo that was important to know. We have discussed the theory too. What is time, trend, seasonality, and stuff like that. Level and the noise and everything was already discussed. This is the algos that we have. Again, guys, LSTM is something that we will discuss at the very end of the deep learning. It is not even going to be discussed in between. I just needed to that LSTM is also used for time series data analysis, and because deep learning always play a role in every algo, guys. Whatever machine learning algo you have seen, deep learning will always be a better option in most of the cases for you know text, for image processing, video processing, normal projects. Deep learning is usually have a higher end. And again, it is not like that every project will work perfectly on deep learning. It is a different story. We will discuss that in deep learning. Let's not discuss that right now. This is all for the videos, guys. I mean, I hope you got the point of all the algos and the difference and the similarities and everything of each algo. Let's move on and go for the next proper one by one step. Thank you for watching the video, guys. Bye.